Hello everybody, welcome to my channel. We have an interesting function here, x squared times ln of x squared minus 1, and we're asked to sketch this graph. Now, in order to do that, the first thing I'd like to do is to find all the asymptotes and all the x and y intercepts, and then move my way towards finding the derivative of the function, so find out where the slope changes, and find the maximum and minimum of the graph if we have any. And then I'd like to move my way to finding the second derivative of the function and putting that equal to 0, and find the concavity of my function and find out if it's concaved up, down, and if it's going to change at any point. Now let's get started. Now, in order to find the x-intercept here, I'm going to have to put y equal to 0, or in order to find the y-intercept, I'm going to put x equal to 0. Maybe I'm just going to use a different color here. So I'm going to substitute x equals 0 into this function, so I will have y equals 0 times ln of 0 minus 1. Now in this, I will either have a 0 because I have 0 times something, but this something doesn't exist because ln of a negative number doesn't exist. So I'm just going to ignore this point. I'm going to move my way to finding maybe the x-intercept by putting y equal to 0. So I would have to put the whole function equal to 0. So now that I have two small functions here, I will have to have either x squared equal to 0, which will result to x equal to 0, which doesn't get me anywhere. We saw that in the previous part. And then, or I could have x squared minus 1 equal to 0, which will lead, for ln of x. So for the second part, ln of x squared minus 1 has to equal 0. Now, ln of what numbers? If you actually know the ln identities, or if you have a calculator, you know that ln of 1 is equal to 0, and ln of 0 doesn't exist, so it's infinity. So therefore here, I know if I want to get this whole thing equal to 0, then I should have x squared minus 1 equal to 1. Correct? Okay, so if that's the case, then my x squared is going to be 1, and then I'll move 1 to the other side, so it will be plus 1, so 2. Therefore, my x is going to be positive negative square root of 2. So those will be my x-intercept. Therefore, if I'm going on my graph, I will have an x-intercept at square root of 2, which is 1.4. So it would be somewhere here, root 2. And then I will have one here, negative 1.4. So that will be negative root 2. Okay, great. Now, are there any asymptotes? So are there any numbers for my function that my function won't work? Yes. So if I have my ln of 0, like looking at this identity here, if x squared minus 1 equals 0, therefore I will not have my function will not exist. So I will rearrange for that, and I will have x squared equal 1. So x equals plus minus 1. Therefore these x equals 1 and x equals negative 1 are my asymptotes. So at x equals 1, my function does not exist. And also at x equals minus 1, my function will not exist either. All right, so the next step is to kind of see if the slope of this change, how is this going to look like? One more thing that I want to actually look at here is the domain of this function. So the domain of this function is my x, so what I have in ln x squared minus 1, it has to be a positive number, right? Because ln of a negative number doesn't exist. And do we know why? If you'd like to know why that's the case, you can actually drop a comment and I'll make a video about it. If not, and you're comfortable with that, we're just going to assume that we know this and we're going to continue. So if I have x squared, if it's a negative number, so if I have 1 or anything actually less than 1, so if I have 0.5, for example, to the power of 2, I'll get 0.25, right? And so therefore it would be a smaller number than 1. Therefore I will have a negative number, so it will be less than 0. Therefore I will not have, my function will not exist. So I know anywhere between 0 to 1, I will not, like, my function will not exist anywhere here, so I won't be here. So my x needs to be greater than 1. And on the negative side, my x needs to be smaller than negative 1. Therefore, in this area here, my function does not exist. So all I need to find out is that what's happening here and what's happening here, and I will be done with my sketch. Now, in order to do that, I'm going to find out what my derivative is, as I promised. So the derivative of this function is actually not as bad as you think. So the derivative of this function would be the derivative of, this is function number 1, this is function number 2, derivative of the first function, which is 2x, times the second function, plus derivative of the second function, so that's 1 over x squared minus 1, times the derivative of inside, what's inside, so that would be 2x, so the derivative of x squared is 2x, derivative of 1 is 0. So this is the derivative of the second function, and we're going to multiply that by the first function. Okay, let's clean this up a little bit. I have an x here and an x here, so that would be an x cubed. And over here I have a 2x, so I will leave 2x ln x squared minus 1. Not much I can do with that, but then I will have plus 2x cubed over x squared minus 1. This will be my first derivative here. Now what I need to do is, in order to find if I have a maximum or minimum, I have to put my y prime equal to 0. So having this equal to 0, this whole square thing, I can actually rearrange this and solve for this. It will be super hard. You can pause the video and try to go through it and see how hard it can get, but I suggest something. So if I have these plus this number, so let's call this m and let's call this n. So if I have m plus n equal to 0, what can I say about m and n? M needs to be 0, and, so pay attention, and n has to equal to 0. Now before, if I had m times n equal to 0, I had to have m equal to 0 or n equal to 0, right? Either one of these could work to make this whole thing equal to 0. But when I have a positive, I have an addition sign between the two functions, then both of these functions should be 0. Therefore, I should find an x that satisfies m equal to 0, and the same x needs to make n equal to 0. So let's go ahead and do that. So let's put m equal to 0. So that's 2x ln of x squared minus 1 equal to 0. Now if you notice, we've done this before, so in order to make this equal to 0, I should have what's inside equal to 1. So my x should be plus and minus square root of 2. We did this in the beginning of the video for the actual function, when we were trying to find the x and y intercepts. And then, or you could have x equal to 0, right? So this is where these are the values where m is equal to 0. Now I have to work with n. Now with n here, I should have 2x cubed over x squared minus 1 equal to 0. Therefore, I should have 2x cubed equal to 0. Therefore, x needs to be equal to 0. Therefore, the only value that they share for 0, I will have m equal to 0 and n equal to 0. So for this if I actually plug this into my function doesn't exist for 0 because it's not in the domain. My domain is that x has to be pretty much, if I were to rewrite the domain, it should be negative infinity up until 1, doesn't include 1, and then has to be 1 and infinity. And 0 doesn't fall into that. Therefore, I don't have a maximum or minimum for this graph. So no max, no min. Okay, that's easy. Now let's see if there's a concavity change or, something's happening there. In order to do that, we have to take the second derivative here. So for the second derivative, I'm going to write my first one here, 2x ln of x squared minus 1 plus 2x cubed x squared minus 1. And I'm going to start taking the derivative of this guy, which is not going to be as hard again. So let's try to do y double prime. And in order to actually make this easier, you could take out a 2. So if I were to take out the 2, it would be a little easier. So I will have 2 open. Now I have this similar, so I have function number 1, function number 2, and there's multiplication between them. Therefore, this will be a product rule. So the derivative of the first one, which is 1, times the second function, plus, again, you can pause this video and do this on your own and get back to me. So plus the derivative of the second one, so 1 over x squared minus 1 times the derivative of what's inside times the first guy. All right, and for the second guy, I have two functions, one on top, so that's function number 3, and then here's function number 4. So if it would be a quotient rule, I would have to take the derivative of the first one, so it would be 3x squared times the second one. In this case, we have minus derivative of the second function, which is 2x, the derivative of the denominator, times what's on top over the denominator to the power of 2. And that concludes my derivative. All I need to do is to actually simplify a little bit here. So first I have ln of x squared minus 1 plus 2, I have 2x squared here over x squared minus 1 plus I have 3, so I have an x to the 4 here and x to the 4 here. Maybe I can add them, so I'm going to expand 3x to the 4 minus 3x squared minus 2x to the 4 over x squared minus 1 to the power of 2. Okay, so let's simplify this. We have, I'm just going to write everything down. And then for this guy, I will have a 3x and minus 2x to the 4. So I have x to the 4 minus 3x squared, x squared minus 1 to the 2. Now I could actually take out an x squared for the one on top here. So I will get x squared minus 3. Okay, there we go. So that's my function. I could maybe take a common denominator of these two, but I don't have to. Now, if I put this equal to 0, again, I will have 3 functions here, if you notice. So I will have, again, my m function, my n function, and let's say we call this a q function. So I will have to have x equals a number that satisfies all of these 3 and puts them all equal to 0 to have this whole thing equal to 0. So let's work with this guy. So if in order to have ln of x squared minus 1 to be equal to 0, I have to have this equal to 1. Therefore, my x is going to be positive and negative of square root of 2, right? Is this going to satisfy any of these guys? If I plug in the square root of 2 here, I will have 2 minus 1 is 1. And then to the 4, so it will be greater than 0 for this guy. And I don't care what, I don't even have to look at this one because it's already not going to put this equation equal to 0. Therefore, I also have no concavity. And this is maybe a little bit more advanced because you don't expect a function to act like this when you get it in high school. It would be a little bit more advanced because you don't get the things that you're expecting to get. You do all the derivatives, but it doesn't really get you anywhere. So you don't get to use any of the things that you know. Therefore, all I can tell you is you have two functions. The only thing that you want to know is that how the function is behaving as you're approaching these lines. And once you know that it would be kind of like a very smooth line that doesn't change its slope. It's pretty much straight, and it goes like that. The only thing I want to find out is the limit here. So what I'll do here, I'm just going to find the limit of the actual function as x approaches 1, x squared ln of x squared minus 1. Okay, what I need to do is to give my function a number that is very close to 1, between 1 and root 2, and find out what's happening here. So let's pick, this is 1.4. Oh, sorry, this is 1, and this is 1.4. So I will give it a 1.2 and calculate. So just plug in 1.2 to the power of 2, ln of 1.2 to the power of 2 minus 1, and you will get a negative number. And so therefore it would be less than 0. Therefore this is going to approach negative infinity. Therefore, as I'm approaching this line, I'm going negative, and I'm just going to continue going like this. The concavity doesn't change. The line, literally the slope shouldn't change either. So that's not the best. I would draw it like this, because the slope doesn't change from positive or negative. It remains positive throughout the whole thing. And I will repeat the same thing on the left side. And if you don't believe me, what you could do limit of x as it approaches 1 through the negative, and plug in, for example, a negative 1.2 and see what happens. So you will get the same thing. You will get negative, and it will just go like this. That's about it. Here you have the graph. If you have any questions, please comment them down below. Make sure you like, subscribe, and comment on my videos. Thank you so much. Bye-bye.